Chapter 7. Motion and Measurement of Distances. Introduction. Motion. Motion refers to the change in the position of an object with respect to its surroundings over time. It is a fundamental concept in physics and is essential to understanding various phenomena in the universe. Types of motion. Motion can be classified into different types based on the object's path, speed, and acceleration. Some common types of motion include linear motion, circular motion, projectile motion, and oscillatory motion. Distance. Distance is a scalar quantity that represents the extent of space between two points. It is a fundamental parameter in measuring motion and plays a crucial role in determining the overall displacement of an object. Measurement of distance. The measurement of distance is the process of determining the numerical value or magnitude of the physical gap between two points. It enables us to quantify the amount of space covered by an object during its motion. Units of distance. Distance can be measured using various units, depending on the scale of measurement. In the International System of Units, SI, the meter, m, is the standard unit for measuring distance. Other common units include kilometers, centimeters, cm, and miles, mi. Instruments for distance measurement. Several instruments and devices are available to measure distances accurately. These include rulers, measuring tapes, odometers, laser distance meters, GPS devices, and more advanced technologies like LiDAR, light detection and ranging. Importance of distance measurement. Accurate measurement of distance is crucial in a wide range of fields, including engineering, construction, sports, navigation, astronomy, and scientific research. It allows for precise calculations, planning, and analysis of various physical phenomena and processes. Relationship between distance and time. The measurement of distance is closely related to the concept of time. By measuring the time taken to cover a certain distance, one can determine the average speed or velocity of an object, which provides valuable information about its motion. Understanding motion and accurately measuring distance are fundamental aspects of studying the physical world. By examining different types of motion and employing appropriate measurement techniques, scientists, engineers, and researchers can gain insights into the behavior of objects and phenomena, contributing to advancements in various fields. What is story of transport? The story of transport is a fascinating journey that traces the development and evolution of various modes of transportation throughout human history. From ancient times to the modern era, transportation has played a crucial role in connecting people, facilitating trade, and shaping societies. 1. Early modes of transportation. 2. Ancient water transportation. 3. Road networks. 4. Innovations in maritime transport. 5. Industrial Revolution and steam power. 6. Rise of automobiles. 7. Air travel and space exploration. 8. Modern transportation and future trends. Early modes of transportation. In the early stages of civilization, humans relied on simple modes of transportation such as walking and animal-powered transportation. Domestication of animals like horses and oxen enabled the development of carts and chariots, which improved mobility and facilitated the movement of goods and people. Ancient water transportation. As civilizations emerged near rivers and coastlines, water transportation became a vital means of travel and trade. Ancient Egyptians utilized the Nile River for transportation, while the Phoenicians developed advanced sailing techniques, including the use of the compass, which expanded maritime trade networks. Road networks. With the growth of civilizations, the construction of road networks became crucial. Ancient civilizations such as the Romans built extensive road systems, such as the famous Roman roads, which facilitated the movement of troops, trade, and communication across vast territories. Innovations in maritime transport. The Middle Ages witnessed significant advancements in maritime transportation. The invention of the magnetic compass, the development of shipbuilding techniques, and the use of navigational tools like astrolabes and quadrant improved seafaring abilities. The age of exploration in the 15th and 16th centuries opened up new routes and led to the discovery of new lands. Industrial Revolution and steam power. The advent of the Industrial Revolution in the 18th century brought about revolutionary changes in transportation. Steam power became a game changer with the invention of steam engines. The first steam-powered locomotives and steamships transformed land and water transportation, enabling faster and more efficient travel. Rise of automobiles. The late 19th and early 20th centuries witnessed the rise of the automobile industry. The invention of the internal combustion engine and the mass production techniques pioneered by Henry Ford led to the production of affordable cars. The automobile revolutionized personal transportation, providing individuals with a newfound freedom of movement. Air travel and space exploration. The 20th century marked significant milestones in aviation and space exploration. The Wright brothers' first powered flight in 1903 paved the way for the development of airplanes. Commercial aviation boomed, making air travel accessible to the masses. Additionally, the exploration of space, including the moon landing in 1969, showcased humanity's remarkable achievements in transportation. Modern transportation and future trends. In recent decades, transportation has seen further advancements and innovations. High-speed trains, electric and hybrid vehicles, and the development of autonomous vehicles are shaping the future of transportation. Additionally, efforts to reduce environmental impacts have led to the promotion of sustainable modes of transportation, such as bicycles, electric scooters, and public transit systems. The story of transport is an ongoing narrative of human ingenuity, innovation, and the constant pursuit of faster, safer, and more efficient ways to move people and goods. From ancient footpaths to high-speed railways and from wooden ships to space shuttles, transportation continues to evolve, connecting people across the globe and opening up new horizons for exploration and progress. How to calculate how wide is the desk? Give some measurements. To calculate the width of a desk, you need to measure the distance between the two opposing sides of the desk. Gather your tools. You will need a measuring tape or a ruler to measure the width accurately. Clear the desk. Remove any objects or items that may obstruct your measurement. Position the measuring tool. Place one end of the measuring tape or ruler against one side of the desk. Make sure it is aligned parallel to the edge you are measuring. Extend the tool. Extend the measuring tape or ruler across the width of the desk until it reaches the opposite side. Keep the tool straight and taut for an accurate measurement. Read the measurement. Look at the point where the measuring tool aligns with the edge of the opposite side of the desk. Read and note the measurement where the edge of the desk aligns with the measuring tool. Ensure you are using the appropriate units, e.g., inches, centimeters. Repeat if necessary. If the desk has irregular or uneven edges, it may be helpful to take multiple measurements at different points along the width and then calculate an average for a more precise estimate. By following these steps and using a measuring tool, you can determine the width of the desk accurately. Remember to take your measurements carefully to ensure the most precise result. Standard units of measurements. Standard units of measurement vary depending on the quantity being measured. Here are some commonly used standard units for different measurements. Length, distance. Meter, m. Kilometer, km. Centimeter, cm. Millimeter, mm. Inch, in. Foot, featuring. Yard, yard. Mile, mi. Mass, weight. Kilogram, kilogram. Gram, g. Milligram, mg. Ounce, oz. Pound, elb. Ton, metric ton or ton. Time. Second, s. Minute, min. Hour, hr. Day, day. Week, week. Month, more. Year, year. Volume. Liter, L. Milliliter, milliliter. Cubic meter, m cubed. Cubic centimeter, cm cubed. Cubic inch, in cubed. Cubic foot, aft cubed. Gallon, gal. Quart, cute. Temperature. Celsius, degree C. Fahrenheit, degree F. Kelvin, K. Area. Square meter, m squared. Square kilometer, km squared. Square centimeter, cm squared. Square inch, in squared. Square foot, aft squared. Acre, acre. Hectare, har. Speed, velocity. Meters per second, meter per second. Kilometers per hour, kilometer per hour. Miles per hour, mf. These are just a few examples of standard units of measurement. There are many more units available for specialized measurements in various fields of study. Correct measurement of length, measurement of the length of a curved line, moving things around us. Correct measurement of length. To measure the length of an object in a straight line, you can use a ruler, measuring tape, or any other measuring tool with calibrated units. Simply place the measuring tool alongside the object and read the measurement where the object ends. Measurement of the length of a curved line. Measuring the length of a curved line requires a different approach. One common method is to use a flexible measuring tape or a string. Gently place the measuring tape or string along the curved path, following its shape as closely as possible. Once the entire length is covered, carefully remove the measuring tape or string and straighten it out. Then, measure the straightened tape or string using a ruler or measuring tool to obtain the length of the curved line. Moving things around us. It seems like you're referring to the act of moving objects in our surroundings rather than a specific measurement. Moving objects around us can involve various actions such as lifting, pushing, pulling, or carrying them from one location to another. The effort required and techniques used for moving objects depend on factors such as their weight, shape, size, and available equipment or tools. It's important to ensure proper lifting techniques to avoid injury and to use appropriate tools like dollies, carts, or equipment designed for moving heavier bulky items. Additionally, teamwork and planning can be beneficial for efficient and safe movement of objects, especially when dealing with larger or complex items. Types of motion. There are several types of motion that can be observed in the physical world. Here are some of the common types of motion. Translational motion. Translational motion refers to the movement of an object in a straight line, where all points on the object move the same distance and direction. It can be uniform, constant speed, or non-uniform, changing speed. Rotational motion. Rotational motion involves the spinning or rotation of an object around an axis. Examples include the spinning of a wheel, the rotation of Earth on its axis, or the movement of a ceiling fan. Circular motion. Circular motion occurs when an object moves along a circular path. It involves both translational motion, motion along the circumference, and rotational motion, rotation around the center. Oscillatory motion. Oscillatory motion is repetitive back and forth or to and from motion around a central position. It occurs when an object moves between two extreme points, such as a pendulum swinging or a vibrating guitar string. Vibrational motion. Vibrational motion is similar to oscillatory motion but occurs at a higher frequency. It involves rapid and repeated oscillations around a reference point, such as the movement of particles in a sound wave. Linear motion. Linear motion is a type of translational motion where an object moves along a straight line path. It can be one-dimensional, motion along a single line, or multi-dimensional, motion in multiple directions. Projectile motion. Projectile motion describes the curved path followed by an object launched into the air and subject only to the forces of gravity and air resistance. Examples include a thrown ball, a projectile fired from a cannon, or a basketball being shot. Random motion. Random motion refers to the unpredictable and chaotic movement of particles or objects. It is often observed at the microscopic level, such as the Brownian motion of particles in a fluid. These are some of the major types of motion that can be encountered in the physical world. Many objects and phenomena exhibit a combination of these motions, and studying them helps us understand the behavior and dynamics of the world around us.